In this example, we're going to investigate the 68, 95, 99.7 rule for normal distributions. In particular, we have scores on a particular test follow a normal distribution with a mean 75 and a standard deviation 8. Notice this is a normal distribution, but not a standard normal distribution. We are not looking at z-scores. The scores on the test have a mean of 75. If we add all of the scores together and divide by the total number of people who took the test, we get 75 as the value. The standard deviation is 8. First, we're going to draw a model that correctly shows the 68, 95, 99.7 rule for this exam. We start with a normal curve, which is this nice bell-shaped curve. The 68, 95, 99.7 rule tells me that 68% of the data lies within one standard deviation of the mean. My mean is right here. I have one standard deviation forward over here and one standard deviation backward over here. So within one standard deviation is this area. That means 68% of my data is right here in this chunk in the middle. That's a huge amount of their data. Most of our data is going to be in this area right near the mean. My mean is 75. That's the value in the middle. If I go up one standard deviation, 75 plus 8, that gives us 83. If I go down one standard deviation, 75 minus 8, that gives me 67. So down one standard deviation, I have got a value of 67. This is telling me that 68% of all of the test scores are between a 67 and an 83. If I want to go further, I can look at the 95. The 95 tells me between two standard deviations within the mean, 95% of my data lies. So here's the mean, here's one standard deviation over, here's the second over. Backward, I've got the mean, one standard deviation back, two standard deviations back. That means in this green area, 95% of my data is here. That's almost all of our data. In terms of our test scores, that means our test scores are going to be mostly between 59 and 91. I arrived at 91 by adding a standard deviation to 83. 75 plus 8 gives me 83. 83 plus 8 gives me 91. I arrived at 59 by subtracting a standard deviation from 67. 75 minus 8 gives me 67. 67 minus 8 gives me 59. 95% of the students who took the test got a score between 59 and 91. Lastly, we're going to look at the 99.7. The 99.7 says between the mean and 3 standard deviations in either direction, I've got 99.7% of the data. So that goes from down here, all of this stuff in the middle, which includes the green. So everything that's blue and green is 99.7% of the data. You can see that past 3 standard deviations, there's almost no area underneath the curve anymore. That's because 99.7% of the data is underneath the curve within 3 standard deviations. The values at our third standard deviation above the mean is given by 99, and the value 3 standard deviations below the mean is given by 51. This means 99.7% of the people who took the exam have a score between 51 and 99 according to our model. Suppose that we had 1,000 people take the exam. This would mean that 997 of them have a score somewhere between 51 and 99, if we followed this model. The 68, 95, 99.7 model is an approximation, but is a very useful approximation that can often give us a good amount of information on our data. What you see in the next picture is an even further breakdown of the 68, 95, 99.7 rule. In our 68, that means from here to here, 68% of the data occurs. Well, if I only take half of that, this would be half of 68%, which is 34%. If I look between the mean and 1 standard deviation above, that's 34% of the data. Likewise, between the mean and 1 standard deviation below, I have 34% of the data. The 95% tells me from this end to this end, I have 95% of the data approximately. Well, let's start by taking out this 68%. If I do that, I've got 95 minus 68, which gives me 27% of the data. That 27% is spread over this area and this area. From 59 to 91, I have 95% of the data. I take out from 67 to 83, that leaves me with 27%, and that's the area here with the area here. Because it's 27% over each of these green pieces, this one will be half of 27%, which gives me 13.5%. Between 1 standard deviation and 2 standard deviations above, I have 13.5% of the data. Between 1 standard deviation below and 2 standard deviation below, I also have 13.5% of the data. If I go further with this, between 99 and 51, so that's 3 standard deviations forward and 3 standard deviations back, I have 99.7% of the data. If I take the 99.7 and get rid of the 95% in here, that leaves me with 4.7% of the data. That means 4.7% of the data is over here and over here. That tells me if I just wanted to look at this portion, I would have half of 4.7%. Half of 4.7% is 2.35. By the same logic, on this side, we have 2.35%. The last piece to figure out is what happens beyond 99.7. The entire curve is 100% of the data. If I want to look beyond 3 standard deviations, I'm going to get rid of all of this stuff on top. I'm going to get rid of 99.7%. That leaves me with just 0.3% of the data that is beyond 3 standard deviations above or below. Half of that is going to be 0.15% above and 0.15% below 3 standard deviations. We can take our normal 68, 95, 99.7 rule and break it into pieces and see that each piece has a specific percentage. This is useful for answering specific questions such as the central 99.7% of the scores are between which values? Well, I know that 99.7% is within 3 standard deviations, so I know that I'm looking between here and here. 99.7% from a score of 51 through 99. Our next question, what percent of scores are above 91? So what percent of the students are above a 91%? Well, that's going to be everything over here. That's the 2.35 plus the 0.15. (2.50%). 2.5% of students scored above a 91% on the exam. What percent of values are less than 67%? Well, 67% is here. That's 1 standard deviation below the mean. If I want less than 67%, I'm looking at all of these possible scores. That's going to be 13.5 plus 2.35 plus 0.15. This gives us a total of 16%. Our last question says, what percent of values are between 59 and 83? 59 is here, 83 is here. I'm going to add together 13.5% plus 34% plus 34%. This is going to give me 81.5% of the data. This tells us that 81.5% of students scored between a 59 and an 83 on this exam. This is how the 68, 95, 99.7 rule works, and how it can be very useful in determining percents for given data sets.